Hello, this is Mrs. Dowell, and I'm going to do a quick live lesson on the assignment 6.05, okay? A little confusing, so I'm going to do just a quick live lesson on this one particular assignment, and this is option 1 to work alone. So in this assignment, it starts out by saying, after a dreary day of rain, that could very easily be today, because we're expecting rain all this weekend. After a dreary day of rain, the sun peeks through the clouds and a rainbow forms. You notice that the rainbow is the shape of a parabola. Okay, so the equation for this parabola is y equals negative x squared plus 36. So there's a couple of things that I just need to point out to you about that particular equation. You already know this, but I want to point this out in order to confirm what you know. What is the degree of the leading coefficient? I'm looking for two things, the highest degree, and then I'll be looking for the leading coefficient. Negative x squared is the first term, okay? So from that first term, we can get two pieces of information, the highest degree and the leading coefficient. Okay. 2. Highest degree is 2, and then the leading coefficient. But the leading coefficient, so if you're looking at the first term, which is negative x squared, what's the number in front of the negative x squared? Well, you need the highest degree, and you need the leading coefficient. Okay, and then 36, well, what happens if I plug in a 0 for x? So I get y is equal to negative 0 squared plus 36. Well, that just simply means y is equal to 36. Okay? So 36 is going to be my y-intercept. Okay, so, and that makes sense because we can see it right here, 0, 36, that's the y-intercept. Now, the leading coefficient being negative 1, what does that mean about my equation as far as end behavior is concerned? So in other words, if the leading coefficient is negative 1, then the end behavior says, and then what about this highest degree being 2? If the highest degree is 2, then so now let's read what we're supposed to do. Create a table of values for a linear function. So I need a table of values, and then it says a drone is in the distance flying upwards in a straight line. Now, I don't know if you know what a drone is. If you live in America, you should know what a drone is. A drone is a non-manned airplane. That means there's nobody actually in the airplane. It is being flown by by a controller on the ground or whatever. So it's an RC. It's remote control. So a drone is flying upwards in a straight line. Okay, great. So what that means to me is that we've got a drone going something like this, upwards in a straight line. Okay, so here's my drone. Okay, and it says it, meaning the drone, intersects the rainbow at 2 points. Okay, so if I'm looking back over here on this page, I could be like, okay, here's my drone. It's flying upwards. Here's my drone. Here's my drone. It specifically states that the drone is flying upwards and intersects the rainbow at 2 points. Okay? So a question for you. Would this work? Could that be the path of the drone?
No, because it said it was going upwards, and that one's just, you know.
Right. Any one of these would work. What about something like this?
No, because it's going down.
Okay, good. No, because it's going down. What about this one right here? Could this be the path? If you were in that drone right there, if you were that drone and you were flying on that path, you would actually start flying underneath the ground. Because we have to remember that the ground is right here. This is the ground. Okay, so could this one right here be a possible path for a drone? Heck no. You would have crashed before you even got off the ground. And there is the other idea that it doesn't connect the parabola twice. Okay, so all right, so we've got an idea of what all of our drones are supposed to look like. So I'm going to get rid of these sample drones here, and we're going to go back and look at the question. So it says, it intersects the rainbow at 2 points. That's a requirement. We have to have a drone that intersects the rainbow at 2 points. We have to make a table of values. The drone has to be flying upward. And it says choose the points where your drone intersects the rainbow and create a table of values, a table of at least 4 values for the function. Okay, so we're going to go back over here, and we're going to be very strategic. Okay, I think it is my opinion that it looks to me as though the drone passes right here. It looks like it also maybe, I think it's hard to tell. I'm trying to find a point where it's spot on. Like, for example, I don't think that point right there is exactly on a thing. Right here, definitely not. Right here, yes, but it would be hard for me to put a drone unless I did a drone like this, unless I said, okay, here's my drone. I'm going to let my drone do this. That path of that drone right there does, in fact, intersect the rainbow twice, and it is flying upwards. So it's possible that we could use that, but I'm not going to use that. Okay? I'm not going to use that. I'm not going to use this and this. And I don't like using this one down here because I'm not really sure. So in my opinion, in my humble but most accurate opinion, I feel like this point right here would probably be the best point for us to use on this side of the drone. Now the coordinates of that point are, and I want to point out to you that the y-axis is ticked off by 2's. Okay? It's 2, 4, 6, 8, etc., all the way up to 36. So we have to keep that in mind. And the x-axis is ticked off by 1's. Okay, so we're just going to keep that in mind when we're trying to find the ordered pairs here. So this is 2, 4, 6, 8. Oh, no, I'm sorry. These are ticked off by 1's. 1, 2, 3, 4. Okay. So the x-axis is -4, and the y-coordinate would be 2, 4, 6, 8, 10, 12, 14, 16. I guess that's 20 right there. It's pretty close, I guess, but it may be off by a little bit. It may not be right exactly on 420. It may not. But then again, it may. So I don't know. Hard to say. So I'm going to go -420. I'm just going to say, okay, -420. And then over here, I want to look for a point that, I love this point right here. That's going to be a great point to use right there, because that's clearly square on. So this is 1, 2, 1, 2, 3, no, 1, 2. So this is 2, comma. Well, if this right here is 36, then this would be 34 and this would be 32. So this is 32. In other words, I'm going to say that those are the ordered pairs for where my drone passes the parabola, the rainbow. So let me see if I can kind of get my drone's path down here. Those 2 points, I'm going to include those 2 points in my table of values. -4, 20. Hope you can see that. -4, 20. And then 2, 32. Those are 2 of the points that will be in my path. All right. Now, it does look to me like possibly, and I can't say for sure, it does look to me like this point right here might also be on the path, and that would be really awesome if it was, because that would be 36, 34, 32, 30, 28 possibly. So maybe 0, 28. I don't know for sure. We're going to check it and see. 0, 28. Okay, so what we need to do now is we need to, let's go back over here to our directions. It says, okay, a drone is flying in the distance, flying upward in a straight line. It intersects the rainbow at 2 points. We've got that. Choose the points where you want your drone, where your drone intersects the rainbow, and create a table of at least 4 values. All right, we're working on this. At least 4 values. Remember to include the 2 points of the intersection. Okay, fine. And so we've got the 2 points of intersection. And, you know, there is one thing that I could do to check these 2 points, because these 2 points are supposedly on this rainbow. Do you agree with that? Is there any way for me to check to see if these 2 points that I picked right here are actually on the rainbow's path? You can plug them into the equation of the rainbow. So let's see. If I take these 2 points and I plug it into this equation and it works, then I know for sure that those 2 points. So I absolutely know for sure that that point is on that parabola. Now I'm going to check my other one. 32 is my y, so this is going to be 32 is equal to a negative 2 squared. Many people might get their order of operations mixed up here and feel like they're supposed to square -2, but you square 2, and then you make it negative. And then this is plus 36. So 2 squared is 4, and so this is -4 plus 36. So I have just proven that the 2 points that I picked are, in fact, on that parabola. Now, we have to find 2 other points. Okay, we have to find 2 other points. Not 2 other points that are on the parabola, but 2 other points to put in our table, because the directions say the table of values needs to have 4 points in it. So I am wondering if I write the equation for my parabola, or my rainbow right here, if I write the equation for my rainbow, I can use that I can use the equation of my rainbow to test and see, not the equation of the rainbow, I can use the equation of the drone to test and see if 0, 28 is on that path. So I'm going to find my slope, and my slope is going to be y1 minus y2 over x1 minus x2. So this is plus positive, so this is going to be 6. 32 minus 20, I believe, is 12. Oh, that's a beautiful slope. So m is equal to 2. That's my slope of the drone. M is equal to 2. Positive 2. Because my slope is positive, that is my proof that the drone is going up. Okay? Okay, so that being said, I'm just going to I'm going to use this point right up here, and I'm going to write the equation in point-slope form. Now, if you can't remember point-slope form, it is y minus y1 equals mx minus x1. Okay, so this is y minus 32 is equal to 2 times x minus 2. Okay, and I'm just going to, actually, I think I'll go ahead and simplify that. I'm going to distribute the 2 here, so that's 2x minus 4, and then I'm going to add the 32 to the other side. So I've got y equals 2x minus 4 plus 32. This equation right here is in slope-intercept form. That means that the y-intercept is 28. So I'm going to move all of this work up over here into the corner. So I know that 0, 28 is also one of the points on this line. Now I need one more point. I would bet that this point right here would also be a point. I would bet. So that's -1, -2. So that point right there is located at possibly -2, 24. So I'm wondering, and I put a big question mark right here, I'm wondering if that point right there, -2, 24, is also on the drone's path. So all I'm going to do is I'm going to take a -2 and plug it into the path of my drone, which is y equals 2x equals 28. Take a -2, plug it in right here. And what do I get? Well, this becomes y equals -4 plus 28. Y equals -4 plus 28. Well, now I can see that that point right there, 24, is also a point on my drone. So here's my third point, or fourth point, -3, 24. Now, if I was really, really good, I would put these in order, which I think I will over here. If I was really good, I would put these in order, and then you would be able to see that the slopes are all the same. So as you can see, this is going up by 2, this is going up by 2, this is going up by 2, and this is going up by 4, up by 4, up by 4. Up by 4 over the up by 2. So it's the up by 4 over the up by 2, which is equal to up 2. Okay, so that's how I have proven that my drone's path is going up. What is the domain and range of the rainbow? Okay, explain what they represent. Do all of the values make sense in this situation? Why or why not? Okay, domain goes from left to right. Okay, so what is the left? Okay, and I should say X represents the domain. What is the leftmost X, the leftmost X on this rainbow and drone situation? The leftmost X. So think about it again. What is the drone's leftmost X value? Or not the drone, but I think, the drone does keep going for sure, but as far as what we're dealing with here, we want to make sure that we are considering the drone and how it relates to the rainbow. I want you to go to the furthest leftmost point. Okay, then tell me, what is the furthest leftmost point? The drone does not go any further than -6 on the x-axis, because if it did, what actually happens at the point -6, 0? If the rainbow ends right there, rainbow hits the ground. -6, 0 is the farmost left point. So we're going to say the domain goes from -6, or from x equals -6. Now, what's the farmost right point? X value, the farmost right X value, because the rainbow hits the ground at +6. Now let's talk about the Y values. That's the range, okay? So I'm gonna delete this. I'm gonna delete this, and I'm gonna put up here range. All right, the range goes from bottom to top. Just like domain went from left to right, the range goes from bottom to top. So now we're looking at the Y values, okay? We're looking right here at this Y, at the Y axis, and we're going to go from bottom to top. So now I need for you to tell me, what is the lowest or the bottommost Y value? Down here, absolutely, 0. Boom. What is the highest? What is the greatest? The top would be 36. So my range, Y, is equal to 0 to 36. And some people write it out in words. They'll go like, range is from Y equals 0 to Y equals 36. Some people will write it out that way, and that's fine for purposes of this assignment, to just write it out and be with it, go with it like that. That's totally fine. All right, so what is the domain and the range? Explain why the domain and range represent. We just did. You just did. You said, well, if you go to the left of the -6, you're crashed. You've crashed. If you go to the right of 6, you've crashed. And then as far as the rainbow is concerned, if you go above 36, you're up looking at the sun, because the rainbow, the highest that the rainbow goes is 36. Okay. What are the X and Y intercepts? I think you know this also. The X-intercept, it's pretty simple. X-intercept right here, -6, 0. The other X-intercept right here, 6, 0. And the Y-intercept right here, 0, 36. And if it wanted the Y-intercept for the drone, well, we figured it out. I think it was 0, 28. So if they wanted that, I don't think that that's what they want. I think they're just referring to the rainbow, because the X-intercept is -6, 0 and 6, 0. But I don't think they want the drone's intercept. And explain what each intercept represents. Once again, it represents the place where the rainbow hits the ground. Is the linear function you created positive or negative? Yep, heck yeah, we even proved it up here, because my slope is 2, positive 2. And then what are the solutions to the system of equations that you created? Oh dear, well, I deleted it. I erased it. But those first 2 ordered pairs in my chart, are the solutions. The solutions would be, where does the drone hit the rainbow? And I think this was, well, I think this was -4 something, which I can't remember right now, and this was something. Anyway, these, you know what they are. These 2 points right here are the intersection points. Okay? So that pretty much covers all of the different